Welcome to my projectbazaar.com. Now let's see about complex SAR image compression based on directional lifting wavelet transform with high clustering capability. Now let's see about the abstract. Here we propose the novel method to compression the SAR image. In this paper, efficient representation of SAR images using DLT are implemented. Two complex SAR image coding schemes using DLWT are proposed. Generalized lifting schemes is a derivative of the lifting scheme in which the addition and subtraction operations are observed into the update and prediction steps respectively. These steps can be any mapping leading to a more general lifting scheme. From LWT we get the four subbands such as approximation, horizontal, vertical and diagonal informations are taken. These subbands are passed to bit plan encoding. In pre-processing we remove the noise from the image. After removing the noise, the image will be quantized by the lifting wavelet transform. The image will be transformed by two steps. First one is the directional lifting wavelet transform. It converts the image from spatial domain to frequency domain. The encoder is made signal independent domain to domain and computationally inexpensive by shifting the bulk of system complexity to the decoder. After quantization, we encode the image by the use of bitplan encoder. This will generate the coded value for an image. After codes will be given to decoding process. After decoding, it will given to the dequantization for reconstruct the images. Finally, we apply the inverse lifting wavelet transform. It reconstructs the original image. This is the flow of our process. Here initially we have to given the JPEG 2000 images input. The input image will pass to the pre-processing step. Suppose if there is any noise in the images, it will be removed. For removing the noise, the Gaussian filter is used. It is a linear widowed filter. Based on the weighted mean, the noise will be removed by the use of Gaussian filter. After that, it will go to the quantization technique. Here we are converting the image as a coefficients. For transforming as a coefficient, here we are using the lifting wavelet transform. So it will convert a image as a subbands. For that, it will use the lifting scheme. So that here we are getting the information such as approximation, horizontal, vertical, diagonal. These types of subbands are given by the use of quantization. So the extracted subbands will pass to the encoding technique. For encoding process, here we are using a bitplan encoder. The generating codebook is a main concept in this process. So bitplan encoder is a code which maps source symbol to a variable number of bits. It can allow source to be compressed and decompressed with a zero error and still be read back symbol by symbol. After encoding, we are getting the bit stream. The bit stream will pass to the decoding process. Here the encoder and the decoder have the same sorting algorithm. Then the decoder can duplicate the encoder's execution path if it receives the result of the magnitude comparisons, and the ordering information can be recovered from the execution path. After decoding, it will pass to the dequantization technique. It will be given to the lifting wavelet transform for reconstructing the informations. So it will convert in the image as an original form. So it is the reverse process of lifting wavelet transform. After applying this inverse wavelet transform, inverse lifting wavelet transform, finally we are getting the reconstructed image. For the reconstructed image, we are analyzing about the MSE, PSNR and compression ratio, bit per pixel values are calculated. Now let's see the demo of our process. Here I am having SAR main.m file. Select this file, right click and run the file. This is our guide design. So initially we have to given the input image. Now I am selecting one image as input. This is the selected SAR image. This SAR image will pass to the pre-processing. So here the noise is removed from the input image. This filtered image will pass to the lifting wavelet transform. This is the result of lifting wavelet transform. This is the approximation, and horizontal, vertical and diagonal informations are getting. This information will pass to the bit plan encoding. This is the encoding result of bit plan. This is the compressed image of bit plan encoding, and this is the bit values of compressed image. After that, we are going to the bit plan decoding. This is the reconstructed image of our bit plan decoding. After that, the reconstructed information will go to the inverse discrete wavelet transform. This is the reconstructed result of inverse lifting wavelet transform. Now I am showing the result of satellite image compression with the help of bit plan encoding. Thank you.